I've casually played disc golf for a few years, and what I've learned from all that experience is that I suck. But aren't sports 90% mental? So I decided to use my brain. Although you might think there's something wrong with my brain, because I made this. My goal has been to throw faster than any human. So we're gonna see if we can break some records.
And before everyone accuses me of cheating, I want to point out that this disc is regulation.
It does have this minor issue of so much kick that it'll break your arm, and a 100-mile-per-hour frisbee going past your face. So naturally, we have to see how bad it would be if you got hit. This ended up being my most labor-intensive project ever. Everything that could break, broke. I mean, heck, it broke twice. One of the main systems took me 10 generations to get working right. I even had to make my own valves.
Like a lot of my projects, the journey is the destination, so buckle up.
Disc golf is just like normal golf, played with discs. You play a series of holes where you try to get the discs into a basket with the minimum number of throws. You typically start with a long-distance drive to get close to the basket, and then you putt it in.
I enjoy making things go really, really fast, so I'm gonna focus on the drive, and my goal is to make the disc go as fast as humanly possible. Actually, faster than humanly possible. And according to the internet, the fastest disc ever thrown was 89.5 miles per hour by Simon Lizotti. So our target is 90 miles per hour. I've been wanting to make something like this for quite a while, and I have a vision of how I think it would work. Imagine a thing that you could hold that gave your arm an extra joint, and it was powered and could spin super fast on command. And then it had the ability to hold a frisbee on the end.
As you swung this thing, it would fire and give you a ton of extra speed. And then a computer monitoring the swing would release at just the right point.
The biggest problem with this design is the reaction forces. It is gonna kick like a mule.
When it accelerates the frisbee, there's an equal and opposite force that pushes into your arm. This could mess up your aiming or even injure you. Thanks a lot, Isaac Newton. But wait, if I launch two frisbees in opposite directions, they'll push on each other and it'll cancel out. So we just need an extra arm on our launcher, and we'll use a weight instead of a frisbee.
I need some kind of power source that I can use to accelerate this arm and launch the frisbee. In the past, I've used explosive blanks to launch stuff really fast, but I don't think they're suitable in this case. And that's because they're just too fast. They release all their energy almost instantaneously. If I accelerated this disc as fast as the explosive blanks would want to, it would basically just break everything.
So my plan is to use really high pressure air. I can shoot this air into a piston, which will make a really strong pull. And then I can attach a chain to it to spin the arm. But that's only half the problem. We also have to stop the arm. You can't just have a hard stop because this will destroy everything. But there's a really cool trick. If we attach the chain to the sprocket, it will unwind as it launches the arm, and then it will wind the other way, which pulls the piston back out, acting like a brake.
I really like this design because there's no extra parts for me to make, break, and then remake, which is what usually happens with these systems.
Holding and releasing the disc is really hard. Humans are crazy, and we're not going to be making a hand. So I'm going to have the disc sit on a flat plane, held down by fingers around the rim. The fingers will have a trigger mechanism that will let me drop them all in sync.
That's the basic design. 2 counter-rotating arms, one holding a frisbee with little claws, powered by a high-pressure air system.
All right, let's get this thing made. Oh crap, this hole's supposed to be over here. This part is too big to fail. If anyone asks, you didn't see anything. Everything is super beefy because the forces and torques are ridiculous. This thing has a lot of round parts, which means a lot of lathe work. You know what? Don't even ask. Cutting square-edged holes is sometimes a real challenge. This is the arm brace and will be formed into the shape of my arm. Hey wife.
Yeah?
Could you see if we have a rod kind of similar size to my bicep?
Yeah, sure.
Very cool. If you want to understand what the heck some of these tools are, check out my shop tour. I 3D printed as many parts as I could, but the forces are so high that pretty much everything had to be metal. Once the parts are finally made, the assembly is pretty easy. So cool.
This is completely ridiculous, but also really cool. So you hold it with this handle and strap it to your arm.
This is the air cylinder that powers it, and this is the chainring that it drives, and this gearbox rotates the arms in opposite directions. The Frisbee sits here and is held in place by these fingers. The little air piston that releases the fingers is in here, and it pulls on these rods for a fast, synchronized release.
This whole thing is powered by a power pack, which you wear like a utility belt. So it's designed to be worn in the small of your back like this. Although if you're feeling chic, you could wear it on your side. And if you're feeling adventurous, you can wear it like a 90s fanny pack, but it just doesn't seem like a great place for a 3000 PSI air system.
The power pack is simple. There's the high pressure air tank, a valve to control the airflow to the launcher, and a low pressure side to drive the Frisbee release.
My first instinct is to strap this to my arm and give it a shot, but that is a really bad idea. For one, I'm running this air cylinder at 6 times its rated pressure. I did analyze its strength and it should be totally fine, but my bigger fear is actually the stuff that's spinning around. If something became partially detached, it could fling around and whip the snot out of me. We are gonna test this really thoroughly before I strap it to my body. Whenever you test something like this for the first time, it's always really nerve-wracking. Anything could happen, and so I'm in the safest spot in my shop. So here we go. 3, 2, 1. That was about 30 times slower than it should have been, which is kind of funny, but also really annoying. Although I think I might know what the culprit is. I'm really suspicious of this gearbox. Everything feels really good in low friction right now,
but if you put a lot of torque through these gears, they try to push each other apart. I think this is shoving them into the side of the gearbox and generating a ton of friction. So we're gonna modify the gearbox to put these bearings between the gears and the wall.
All right, hopefully it works this time. 3, 2, 1.
Why?
All right, so I've been doing a lot of testing, and I think that this valve is part of the resistance, trying to undermine my disc launcher from within.
The reason I used this valve is that someone on Amazon said it worked for their potato cannon.
And I thought, sounds great. I'm basically launching a potato too.
Yeah, cool story, Mr. Potato Head, if that even is your real name.
I just did the math, which I should have done before, on the airflow that I can get through this valve, and there's not a chance that it'll work.
This valve is between the tank of high pressure air and the pneumatic cylinder. And the problem is that it has a tiny little hole, which only lets a little bit of air through, so the piston moves really slow.
Unfortunately, I can't get a suitable valve quickly, and I want it right now, so we're gonna make our own valve.
We'll start with a giant hole that all the air can go through. Then we'll add a piston that can open and close the hole. Pressurizing this side will push the piston down and open the valve. We can even use our high pressure air to do this. We just need a small valve to turn this piston on and off, which is a perfect use for this valve that I thought was useless. And you know the drill, we just gotta make it now. This is the valve piston. It goes in like a glove. It really is pretty simple. I did integrate a safety stick, which prevents the valve from opening until I'm definitely ready. Let me show you the difference between these valves. Here's the old one.
3, 2, 1.
Now I'm gonna show you what a real valve does.
2, 1.
It's just too much stress for the balloon to handle. The balloon is gone in 5,000ths of a second. Balloons are cool, but it would be really cool if it actually works.
3, 2, 1.
Man, so slow.
This is starting to get pretty annoying, actually. Come on. All right, I think I found another problem. I'm very hesitant to say the problem because I've said that 3 times already. Basically, we have a bottleneck in our bottleneck. Let me show you.
Oh, come on. Hold on, I don't have the right tool. Okay, let me show you.
And this is the regulator.
The tank actually has a super duper high pressure inside of it, and the regulator allows it to output a constant lower pressure even as that pressure inside the tank changes.
Here's what's inside. It's a lot of interesting stuff, but the main takeaway is there's another tiny hole. Tiny holes are bad. All right, it's starting to get a little bit complicated, but we're gonna add a second tank that has no regulator.
The main tank pressurizes the secondary tank before we fire. The second tank has a big hole which can deliver all the air when we fire. All right, let's try again. Ignore the fact that it didn't release, that's a software bug. The speed is way better, but what is with this kick? Oh my goodness, I know what is happening.
I think of stupid and smart as a continuum. You have stupid over here, smart over here, and everything in between. But what you might not realize is it's actually a circle, and it's possible to do something that you think is really smart, but you actually wrapped all the way back around to stupid, which is exactly what I did right here with this torque problem.
Looking at it from above, things are great. All the forces cancel out. But from this view, the top arm is pushing this way, and the bottom arm is pushing that way, which wants to twist the launcher, like a lot.
So I calculated how much torque this would put on your arm, and it's about the torque output of a Honda Civic. So I'm gonna remove this lower arm. This will cut the torque in half, although it does mean we're gonna get the kick that I was trying to cancel out. So to try to make that better, I'm gonna make all the mass removing up here as light as possible. The downside is I have to redesign and remake everything that moves. Yeah, that's not great.
CNC is the best. I call it the Finger Flinger. The idea is that the disc sits on a little finger at the end of the arm. As the arm rotates, the disc will swing out. And when it's at the right point, you can drop the finger to let the disc fly. The real finger looks like this and is held in place with a metal wire. The wire is held and released by a mechanical trigger at the base of the arm.
Including the counterweight, this weighs 20 times less than what we had before, which should really reduce the kick and the torque. One little tricky thing is that before it starts swinging, the disc can just flop and fall anywhere. So there's a little plastic clip that holds it in place before it starts moving, and then it can just swing away freely.
It's cool and all, but does it work?
3, 2, 1.
Hopefully that was a fluke. It can throw all right sometimes, but if there's any wobble, it just pops out. Slight redesign. Hopefully this holder will keep it stable. All right, let's try it. I think I somehow managed to make it worse. This is the Super Duper holder, which Super Duper supports the disc.
3, 2, 1.
Oh, I got it wrong. It's the Super Duper waste of time.
I just don't see any way of making the disc stand here without making this too heavy. I'm gonna go back to the original holder and try to make it really light.
Any mass that can't tell me what it would say it does here is gone. Everything is skeletonized, lighter fasteners, and I modified it to use the finger trigger because it's a lot lighter.
So before I sink any more time into this, I want to actually test it with me holding it. I'm going to do it at an extremely low power. This will let me test the whole system. It'll also let me test the throwing modes. So up until now, I've been using bench mode, which if I hold this button for 2 seconds, it'll trigger it. But it also has throwing mode. There's an accelerometer and gyroscope on the launcher that monitors the tilt and rotation of it. When it reaches a certain point in the throwing motion, it will trigger it to fire the Frisbee.
Time to just go for it.
Wow. 3, 2, 1. It seems like the disc isn't releasing at the right point. Oh!
You know, I think that assessment might have some merit.
Something somewhere is broken and I don't know what it is. So I'm gonna stop before I hurt myself and try to figure out what the heck is going on.
You solve one problem, you create another. The discs are jamming.
Oh my gosh.
Now that we're going really fast, I think the extreme acceleration forces are jamming the triggers so they don't open, which means that we get to redesign and remake the triggers. I think you know the drill at this point. Okay, this should be practically unjammable. All right, 10% power, here we go. All right, that looks great. 25%. What?
So it kind of looks like the disc is catching air under it and getting forced out.
I love how we now have the opposite problem of jamming. I'm making a quick and dirty air shield to see if I can improve the situation. This should block air from flowing under the front of the disc. All right, 25%. Promising. How about 50? Nice. I think this actually works. 75%. We're going for it. 2, 1. The disc popped out immediately.
A lot of stuff just happened. We broke the carbon fiber tube, which I don't think is that big of a mystery. The disc popping out early is just really, really bad.
Normally, most of the energy goes into the disc, and when it's released, it takes it away. But when the disc pops out early, all that energy goes into the arm, which makes it go super fast, and then slam into the stop system with gusto.
You could say it turns the brake system into the brake system.
We're gonna replace the tube with titanium, which doesn't shatter. Now the real mystery is why the disc is popping out almost immediately.
I don't think this is aerodynamics this time because it's happening almost immediately before it starts going fast. I think this is actually G-forces.
The disc is going from 0 to 60 in a few thousandths of a second. This pushes the disc into the arm with over 100 pounds of force.
I think it's pushing the disc so hard that it bends like this, which lets it pop out of the fingers.
The acceleration begins immediately, which is why the disc would fly out when it's not even going fast.
So my thought is, if there's no gap to squeeze through, then it can't squeeze through.
Let's put that shower thought to a test.
This fully supports the back edge of the Frisbee, which will hopefully keep it from popping out. I'm using one of the trigger fingers to keep the disc in. Then when we're ready to fire, we can open the trigger finger and the disc should roll out of this holder.
I'm so tired of making grippers. Please work. 3, 2, 1. Yeah, that's definitely gonna be a no for me, dog.
I'm really tempted to make a custom solid metal disc, which can't bend, but that would be deadly, and also not regulation. I think the answer is to pull on the disc from the front. This will want to stretch the disc out rather than compressing it, and it shouldn't bend. So that means we get to redesign and remake the disc holder for, I don't even know, the 100,000 millionth time.
Before I sink a ton of time into making a nice gripper, I want to confirm that pulling on the disc actually works. This simple prototype holds under the rim, but it doesn't release. All right, 75% power, here we go. I think this concept works. Also, I was wrong about this one not releasing the disc. Trying to stop the Frisbee broke it. I couldn't have hit more things if I tried, but as far as I'm concerned, that is the sound of victory. I think. We just have to make it for real and find out. It's 95% carbon fiber because I need maximum strength and minimum weight. It's basically the same way you make a drone.
Carbon fiber, titanium, aerospace grade aluminum, all to throw a piece of plastic. You'd think we're trying to go to the moon here. This is just like the prototype, except there's a little trap door holding the disc in place.
If this doesn't work, I give up.
3, 2, 1. Finally, it works. This has been such a slog. This is the most time I've put into any project.
And a lot happened, so let me summarize. We made the original design, which had bearing issues. Then we had a series of pneumatic bottlenecks and made our own high flow valve. We realized the launcher would twist your arm off. Then we wasted time trying to make a Finger Flinger with 3 generations of stabilizers. We backtracked and made the super light gripper, which wouldn't let go. So we developed a new trigger finger. Then as we started to go faster, we ran into aerodynamic issues with the holder and had to make a windshield. Then as we accelerated even harder, the 3-finger holder couldn't handle the G-forces. So we went off on a tangent trying to make a wraparound holder, which didn't work. So then we made a prototype pulling on the Frisbee holder, which worked. I made another wooden prototype, which I didn't show because it was boring. And then we made a space-age certified carbon fiber prosthetic hand.
And all I want to know now is, can it throw faster than a human? Because if it can't, that would be really, really disappointing.
Remember, the speed to beat, 89.5 miles per hour.
I've got a setup that we're going to use to measure the speed of the high-speed camera. But before we do that, I'm gonna throw the disc so that we get a human baseline. I already know that I suck, so you don't have to tell me that.
All right, it's the robot's turn.
3, 2, 1. "85 miles per hour at 40% power. That is what I'm talking about.
All right, let's step it up.
3, 2, 1.
Wow, that's it.
Could we do 100 miles per hour? I bet we could. Max power in 3, 2, 1.
That obviously wasn't supposed to happen that way. It looks like the centrifugal force was so high that it pulled the gripper off the titanium rod. I have the clamps maxed out, so to fix this would take some new parts. Since we're already exceeding 90 miles per hour, let's just call 75%, 100%. I grabbed some dimensions off this still frame before impact, and I calculate that the disc is going about 115 miles per hour. But it is a weird perspective, so take that with a big grain of salt.
I think it's a really bad idea to hold this launcher. The disc can come off, and when it does, it's deadly. And on top of that,
Blah, 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 blah. Boring. We've demonstrated that it's fine at lower power, so let's do it. But we are not going over 15% power.
All right, here we go.
3, 2, 1. Yeah, it's probably a good time to end it. I forgot to aim. This thing is amazing. I love this. It's fast, but how far can it go? I really don't want to take it to a park. This is the kind of thing that generates interest that you don't really want. So thankfully, we have a family friend with a really long field. I bet it's gonna go so far.
3, 2, 1. Directly into the manure.
All right, let's try again.
3, 2, 1.
Do a barrel roll! Do a barrel roll!
My very shallow understanding is that discs flipping over is a fundamental behavior. How much discs want to do this is so important. It's actually one of the ratings for the discs. I'm using discs that don't want to flip over, but they're not designed for the speeds that I'm going, and they're still wanting to flip.
I tested all the discs in all the configurations. Some are all right, some are terrible.
I'm getting about 550 feet, which is less than half of the human distance record, which really highlights how insane that record is. So you'd think if I'm throwing it faster than any human, it would go further than any human can throw, but it's actually really complicated. Discs are basically wings and gyroscopes.
How much the disc wants to flip and how efficiently it flies is extremely dependent on the design.
I think if I want to come anywhere near the distance record, I'm probably going to have to design my own disc for the speeds that I'm throwing at. And I also think I'm going to need a lot more spin. When the disc spins, it stabilizes itself from tipping just like a gyroscope. And I think I'll also need a really strong tailwind.
You know what? Hold on. Oh, that's really close. But I'm not a woman.
So I brought the wife out to press the button, in which case I think it counts because she's a woman.
Who could argue with that?
Who could argue with that?
All right, here we go.
3, 2, 1.
Okay, not the strongest start. Let's try again.
3, 2, 1. Whoa. That was a good one.
You can see how far it went. 167 meters, approximately.
What was the record again? You know, I think that might be for the best.
I can't put my finger on it, but something about this just doesn't really feel quite legit.
I do think it would help if I was holding it.
Do you want to hold it?
No.
So this thing will let you throw a frisbee faster than a human, but a sacrifice must be made. It'll either break your arm or possibly kill you. Not exactly the most useful thing ever, but I think it's a good proof of concept. I learned a ton, and I have a lot of ideas on how I can make it safe, and how I could launch the frisbee really far, which I think is a super interesting problem. And I know this thing is powerful, but I want to get a better visual. So we're going to shoot it at some melons just to see what happens. But before we do that, I want to talk about getting these videos made. So I just spent 8 weeks designing and building and testing this thing.
And I still can't believe that's my life. It is so fun, and I'm so thankful to be in this position.
Projects like this have zero commercial potential, so my ability to make them is totally dependent on your help. So if you want to help me make more projects like this, there's a few things that you can do. The first thing you can do is subscribe to the channel. This helps me get sponsors.
You can support the projects directly on Patreon or by picking up a sweet shirt.
And the final thing you can do is take a minute to check out this video sponsor. I get messages every single day from people who want to learn to make stuff like I do. And the simple answer is that you learn a specific set of skills which you apply to solve various problems. But picking up that set of skills is the hard part. And it's why I think the sponsor for this video is really important. It's a company that I've wanted to work with for over a year, and they're called Brilliant. I love tools, and this is an amazing tool for learning. What they do is they take a subject like linear algebra and they present it in an interactive and hands-on way. So you're solving real problems, you're seeing the results, and it's a really effective way to learn. And linear algebra may seem esoteric, but I use it all the time. I found that if I spend a little bit of time learning every day, it's just insane how much progress I end up making in 6 months. It's kind of like working out, except for your brain. Brilliant is really good for this because they take these big meaty topics where you don't even know where to begin, and they divide it up into little chunks that you can do one every day, and before you know it, you know a bunch of new cool stuff. Right now I'm trying to improve my statistics game. I'm working through all the statistics lessons. It's kind of inspiring me to try to beat the house. We'll see. So if you want to level up your skills and become more capable as a human, check out Brilliant. All you have to do is go to brilliant.org/stuffmadehere to sign up for free, and the first 200 people will get 20% off their annual premium membership. Learning and applying knowledge is definitely one of life's great joys, so I hope you check it out, and that's it. Thank you, Brilliant, for sponsoring this video, and thank you for listening.
Time to find out what would happen if you had an exceptionally soft head and got hit by this.
3, 2, 1. Anyone want some cantaloupe? Fresh cut. Woo!
That seemed like a good one.
I know most people are stronger than a melon, but man, I would not want to get hit by this. That's all I've got until V2, assuming I make it. I hope you enjoyed this project and maybe you learned something. If you feel the urge to get out there and make something or learn something, I would recommend acting on it. It's a source of great joy.